Microphone technologies have developed almost beyond recognition over the last 50 years. Most recently, the advent of MEMS have enabled a new generation of consumer audio applications such as ultra-thin smartphones and in-ear hearing aids. Indeed, many contemporary icons such as the Apple iPhone simply wouldn't exist were it not for the revolution in miniaturized microphones. Yet despite their undeniable attractions, consumer microphones and their associated digital signal processors suffer many shortcomings compared to the human auditory system. For a start, microphones cannot tell you where a sound is coming from. And although directional microphones do exist, these need to be pointed physically towards the sound source, assuming there is only one target and its location is known. Second, microphones cannot separate individual sound sources in complex reverberant environments. Now, I'm not talking about frequency filtering, but the ability to isolate a single speaker from many with no prior knowledge of the location of the speaker nor the number of speakers. And third, a single microphone or even a pair of microphones cannot record the world around us as we hear it. Instead, we're reduced to a largely monaural or single-channel world. More than any other factor, I believe this is a major impediment to the intelligibility of voice communications. I'm David Nugent, the co-inventor of Quaudio, the world's smallest, three-dimensional, intelligent, software programmable microphone array. In these videos, I'll demonstrate how Quaudio can be embedded into any consumer device to enable a vast range of audio functions such as software-defined directionality, stereo or surround sound recording, sound source tracking and isolation, and extreme background noise suppression. So what exactly is Quaudio? Well, first, it's an arrangement of 4 microphone capsules located at or near to the corners of a regular tetrahedron. Audio signals are processed by a simple yet sophisticated algorithm to determine the incoming angle of individual frequencies. This process is nearly deterministic and consumes negligible amounts of processing power. By deconvolving the frequency domain into the spatial domain, we can perform advanced audio functions such as blind source separation, multi-speaker isolation, background noise elimination, and stereo or surround sound capture. And this is just the beginning. Now, at this point, I want to stress 2 things. First, Quaudio knows nothing about the human voice and its frequency characteristics. Its ability to separate one human voice from another, or indeed one human voice from omnidirectional background noises, is not because Quaudio knows what a human voice sounds like and employs isolation filters. That's not how it works. Instead, Quaudio isolates sound sources, whether they be human or not, based on their spatial separation. Second, I'm sure many of you will have heard of a technology called ambisonics. First developed in the 1970s, this recording technology relies on tetrahedral sound field microphones to perfectly capture and reproduce a 3-dimensional sound field at any point in space. Well, Quaudio is not ambisonics. For a start, the arrangement and design of the microphone capsules is different. But more fundamentally, Quaudio tracks and isolates sounds through localization. Ambisonics, by comparison, can't tell you anything about where a sound is coming from. So Quaudio is not ambisonics. Okay, that's enough of the pillow talk. What does Quaudio actually look like? Well, here's a demonstration model. It's a prototype and it comprises 4 omnidirectional MEMS microphones, 2 on either side of a PCB. These are arranged such that the diaphragms of these MEMS correspond to the corners of a regular tetrahedron. This microphone array is incredibly thin. The thickness of the PCB itself is 1.6 millimeters, and each MEMS mic, the thickness of each MEMS mic is only 1.1 millimeter. So the total thickness of this microphone array from the top side of the upper MEMS to the lower side of the lower MEMS is only 3.8 millimeters thick. That's roughly half the thickness of the iPhone 5, which is one of the thinnest smartphones in the world. For applications such as a cell phone where you might not want two acoustic portals on the display side, it's also possible to have a single microphone on the display side and 3 microphones on the rear side. The upper microphone can easily be hidden underneath the interface between the screen glass and the bezel or the surrounding bezel of the phone. Now, another thing to bear in mind is the rotational symmetry of a regular tetrahedron means that quaudio can track and isolate sounds in any direction or any orientation around the microphone, not just in these planes, but in any arbitrary plane around the device. And of course, because it's all done in software, it can do this tracking not just in a single plane, but in multiple planes at the same time. Now, for demonstration purposes, I'm going to be limiting myself to angles in this horizontal plane, but you'll appreciate that the angle or the orientation of that plane can be changed very straightforwardly simply by changing the order of the microphones.
Quaudio was invented by Banu Gunal, Hussein Hachihababoglu and Amit Kondos at the University of Surrey, and me, David Nugent, at Elucidaire. Quaudio is the subject of international patent filings. To discuss licensing opportunities, please contact me, David Nugent, at the email address shown here.